So let's try some examples with these new theorems. Now notice this first example says we are actually proving a theorem. Okay, so we've done this before. When we prove a theorem, what do we got to remember?
We can't use that theorem as a reason.
Okay, so we're going to have to use other ideas. One thing to notice is, and if you're like, what's theorem 6.6? If you look back in your notes, or you can even just look at what they're giving you.
Right.
They're giving you segment AB is congruent to segment CD. So let me label that. And segment AD is congruent to segment CB.
Okay, so this must be the opposite sides opposite sides are congruent theorem.
Yes. That we're trying to prove basically that if we give you that, then it is a parallelogram.
Right.
By that theorem. So we're trying to prove this theorem, why it actually works.
Okay.
So one thing to kind of notice, and I'm hoping you're seeing this, is that in that picture, what else is drawn besides a parallelogram?
Well, they've also got a diagonal in there. And I am just thinking that if we're proving this theorem, we're not going to be using that as a reason, but we're probably not going to be using some of this other stuff about parallelograms, but it's also forming some triangles.
Yes, I love that you're seeing that. So we do have a couple triangles in the picture. So if we can prove those triangles are congruent, that can help us prove some other things that could be congruent. And the goal is to prove it's a parallelogram. And we know a parallelogram, based on definition, opposite sides are parallel. So if I could show that somehow, then I have a parallelogram.
Okay.
So let's keep going.
All right, so I also know that AC is congruent to itself by that reflexive property.
Good work.
So therefore, I'm going to know that the triangles are going to be congruent using side, side, side. So let's call them triangle CDA and ABC.
This is going back to chapter 4.
Yeah,
it's been a while.
This is going back.
Okay. So, and notice again, we're talking about quadrilaterals, but triangles are coming in to play. All right, so we have some congruent triangles. Now, if you prove congruent triangles, what else is true?
All the corresponding parts are. So I could talk about the angles too. Okay, so like I could talk about, let's see, like angle DCA and angle CAB.
Now, think about, some of you might be wondering, why is she talking about the angles? But don't, when you prove some angles, certain angles are congruent, doesn't that prove parallel?
It does. And if I'm trying to prove that this is a parallelogram, I'm guessing it's going to be by definition because I'm trying to not use these theorems that we're learning. So I'm trying to get to where I've got some alternate interior angles that are going to be congruent.
Okay. So we know these are congruent.
Yeah, and I'm actually, and that I know because of CPCTC, that corresponding parts of congruent triangles are congruent. And I'm going to go ahead and, I see another set of angles that I'm going to talk about in a minute, but just knowing this, I want to go ahead and move to the next step.
Okay.
And say that because those alternate interior angles are congruent, I know that CD is parallel to BA.
And I like that you kind of move to that because you want to just think about, okay, what does that prove?
Right.
So that proves these are parallel.
And that reason is because of the AIAT converse, the alternate interior angle theorem converse. Which, again, when I'm proving parallel, I'm using the converse theorem.
Exactly.
Okay, now, there's another set of angles to help me prove the other set of lines parallel. I'm going to talk about angle BCA is congruent to angle DAC. And I would go ahead and put that in the same step of my other CPCTC.
That's step 4?
That's step 4. Just because they're both based off of the same reason.
Exactly.
And I don't really need to have one before I start stating any, or have, I can't have both of them before I start stating any parallels.
Exactly.
I just wanted to separate them so we see where that flow comes from each
Good.
one. All right, so then that reason, or then I know that because of that, I know that the CB is parallel to DA. And again, because of AIAT converse.
And I like that. I do like that you separated that out, so you could kind of see that connection in a sense.
Yeah.
All right. So now what?
Well, now we've proven that the opposite sides are parallel, so now we can say that ABCD is a parallelogram by definition of parallelogram.
And notice I use the symbol. And I like that you're using the definition. Anytime you're proving a theorem, definitions can be used for sure. All right.
Okay. So now we're going to take a look at another proof. This time, we're given some triangles that are congruent, and we're going to be proving that this is a parallelogram. Notice we're not proving a theorem this time. So we can use any of these theorems that we've learned as reasons if that helps us too. And I want you guys to notice what triangles we have that are congruent. P, Q, oh, and my T went away.
Right there.
Where did my T go? Okay, P, Q, T. So this triangle right here is congruent to R, S, T. So this triangle down here. So these are the triangles that are congruent. Sometimes it helps to mark those somehow.
I do like
just so you're aware of which triangles you know are congruent.
Now, I do like what Ms. Huckabee said also was the fact that since this doesn't prove it and you're not proving a theorem, you can use any of the theorems. You could use the definition again if you wanted to. And honestly, on this one, I can think of a variety of ways to do this. But it just depends, right? Don't limit yourself. Some ways will take a lot more steps, and that's okay. But, you know, think about all the different variations, okay?
Yes.
One thing I'm noticing is the two triangles that are congruent. Notice that, like, the whole idea of, like, opposite angles are congruent probably isn't going to help us.
Probably not, because it's not a whole angle that we're talking about.
And even opposite sides are congruent. Notice that proving those parallelogram by opposite sides are congruent, they only have one pair of opposite sides that are involved in those triangles. So that might limit us. Also, consecutive interior angles, okay? All those things. So, again, think beyond, not just the ones that we already are really comfortable with, okay? So here's what I'm thinking. I'm thinking, and I can think of a couple different ways that will allow us to do this. I'm thinking about the fact that, let's do, I'm going to do it this way. What about segment PQ is congruent to segment RSR, and that's because of CPCTC.
So PQ is congruent to SR. Great.
And that's because of CPCTC. Now, notice that already gives you one pair of opposite sides here congruent. I'm thinking also angle TPQ is congruent to angle SRT.
Okay. And that's true also for CPCTC. So can I go ahead and just leave that as in the same step? I'm going to go ahead and take off the 3 then and leave that as part of step 2.
Now,
love that.
Now, you might not
why did you use that angle?
Because I'm noticing, well, they are congruent because those triangles are congruent. I'm noticing that those angles are alternate interior angles.
Okay.
And I know if alternate interior angles are congruent, that proves some parallel.
Okay.
And so I can go ahead and say in step 3 that segment PQ is parallel to segment RS, or SR, however. And that's because of AIAT converse.
3. Yes.
And this is what I mean by don't, like, limit yourself. This is one that we sometimes forget about. Notice now I've proven that basically in that particular quadrilateral, one pair of opposite sides are congruent and parallel, which means it's a parallelogram.
This is the one theorem that I would say people forget the most.
And I purposely did this because it's a very useful theorem that you will probably need to know for a quiz or test. So I can go ahead and say, prove that PQRS is a parallelogram. And that is because, how do we want to word that? One pair of...
I usually say one pair opposite sides
congruent and parallel, or parallel congruent.
Yeah.
Now, another way I could think about this, and you don't need to necessarily write all of this down, you could also prove that PT is congruent to a TR, and then ST is congruent to S or TQ.
Right.
And then state that the diagonals bisect each other, which means it's parallelogram as well.
Right. But I'm glad you did this approach because I think it's good for them to be able to see the one pair of opposite sides parallel and congruent.
Well, and this is unique to just proving parallelograms. Right. Where the other theorems kind of go both ways in a sense.
Yeah.
All right. Now, our whole goal this whole section is to prove a parallelogram. Okay? So we've proven with proofs, 2 column proofs. We're also going to prove by using a coordinate plane. All right? There are 3 methods in doing this. You will have to do this on a test or quiz, and you need to get comfortable with the different ideas of doing this. Okay?
In fact, you'll probably have to do this on a couple of different tests.
Yes, exactly. So get comfortable with it. Now, the good thing about it is the stuff that you're doing on this problem is stuff we've done before. Okay?
Right.
And it's actually algebra concepts. So show that, and in giving you vertices, are vertices of a parallelogram. Now, we drew a picture of it just so you can see a sketch. That's not showing.
Yeah.
Drawing the picture doesn't mean you showed that it was a parallelogram.
Right.
Showing means you need to justify it, prove it. So if we're showing that opposite sides are parallel, this is method 1. Okay, we're going to do it a couple other methods. That is by the definition. Yeah,
okay.
This is by using the definition essentially. Now, why could I show that opposite sides are parallel to prove it's a parallelogram? Well, because the definition says so. Let's think about why this would help us. If opposite sides are parallel, what does that basically mean?
That means if I'm thinking about it in a coordinate plane, they'd have the same slopes.
So this method 1 is all about the slope, all right?
Okay.
So reminder about the slope formula, all right? So the slope formula is your y2 minus y1 over your x2 minus x1. So you're basically using the slope formula. Now, how many times are we going to use the slope formula?
Well, 4 times, right?
Yes.
Because I'm going to need both pairs of opposite sides.
Again, show the opposite sides are parallel, you need both pairs. So I always tend to do the pairs, kind of pair them up. And again, we're showing it's a parallelogram, so this should be a parallelogram in the end.
Okay. That's good to know.
So let's start with the side AD. So if
All right.
I was finding the slope of side AD, right, and they give you the coordinates up here, so you can look down here. I don't even always draw the picture.
In fact, I would encourage you guys to not just draw the picture.
Exactly, because it sometimes limits you.
Yeah.
So using the coordinates. So let's do y2 minus y1 over x.
Yeah, -3 minus a
-1, so that
plus
becomes
1.
plus 1. So this becomes a -4 over
-2.
-2, so the slope is 2.
Okay.
Okay, now
The opposite side of that.
the opposite side of AD is BC, so we can go ahead and find the slope of BC. So we're using the coordinates of B and C.
Okay.
So that would be
So like
what?
-2 minus 2 over 1 minus 3.
So this is a -4 over, that should be a 3, sorry, over -2, so that is
2.
2.
So, okay, those have the same slope, so those lines are parallel.
okay, so
We've
that
just
means
we've shown the work to say that.
Now, if they ever asked you to explain, which we're pretty good about asking you to do that, you would say, well, why are these parallel? Well, because they have the same slopes. Okay? So that's kind of the idea. So we're going to keep going with the other 2 pairs of sides, so AB, and do the same thing for DC. So
Okay.
I'm going to kind of go through this one
A little
quickly.
quicker.
And again, guys, you can pause it, check it with us.
Yeah.
All right, so AB.
2 minus 2 over 3 minus a -1, so 3 plus 1 would give us a 0 over 4, which is 0. And if I do DC, I'm going to take -2 minus a -2, so plus 2, over a -3 minus 1, which is a 0 over a -4, which is still 0. So those are the same slopes, so therefore those lines are also parallel. And again, if we asked you to explain, we know they're the same slopes, so therefore they're parallel lines.
Exactly.
So go ahead.
So that's basically method 1. All right. When you do this on a quiz or test, we're probably just going to say, show that this is a parallelogram. So you would have to choose the method you're comfortable with. Often what I see people do is they'll only do 2 slopes. Okay. You're going to have 4 different slopes you got to find.
Right.
So keep that in mind. All right. What's method 2 going to look like?
Method 2 is going to be talking about that the opposite sides have the same length. So opposite sides congruent is, is the theorem that we're using here. So how do I find the length of a side?
Distance formula.
Distance formula. And don't just draw a picture and count.
Nope.
We're going to be looking, and most of the time we won't give you vertices that you could have done that with anyways, but we want we want to see the distance formula. Now, how many distance formulas are we going to need for this problem?
Well, because they're all the opposite sides you're trying to figure out. So that means 4 different sides.
So 4 distance formulas if you use this approach. So you have the 4 slope approach or the 4 distance formula approach. So let's go ahead and take a look.
4 of everything.
4 of something, yeah.
Yes.
All right. So let's start with segment AB. To find the measure, and I'm going to leave the segment bar off because I'm talking about its length. So the length of AB, I'm going to take the square root of
be 3 plus 1, so 3 minus a -1 basically, squared plus 2 minus 2 quantity squared.
So the difference in the x value squared plus the difference in the y value squared. Great. So if I simplify this a little bit, I've got 3 plus 1 would give me
4
squared 16.
That's 0.
So 0 squared is still 0. So square root of 16, which is really just
4.
4. There's side AB. Okay, let's move on to the next one. Now these, it doesn't matter if you want to just go in order, you can, or if you want to pair them up, you can. I'm going to go ahead and pair them up because I like that idea of keeping those opposite sides together because they should be congruent. So what side is opposite AB?
DC.
So let's go to DC. All right, so for that one, I'm going to take what?
Let's do 1 minus a negative 3, so 1 plus 3 squared plus a negative 2 minus a negative 2, so that'd be plus 2 squared.
All right. And that's going to give us 1 plus 3 would give us what?
That'd be 4 squared, so 16
plus
0.
0 again. And
equals 4.
Still radical 16, so still 4.
And we should get the same value if we're showing it's a parallelogram.
Right.
Now, again, guys, going back to that picture idea, I know that you look at it and you're like, okay, those are horizontal line or segments. Yes, this is a proof, just not in a 2-column format.
Okay, so let's go ahead and let's take a look at side, let's see, we've got AB, so let's start with AD.
All right, AD, so square root AD. So let's do negative 1 minus a negative 3, so plus 3 squared plus 2 minus a negative 2, so 2 plus 2 squared. So let's see, AD is equal to, all right, that's going to be a negative 2 squared, which is 4. Plus 4 squared is 16, so the square root of 20. Now, do I need to type that in my calculator?
Well, we're just showing that the opposite sides have the same length. We don't have to necessarily show that they are, what their lengths are.
Yeah. You could simplify that in radical form, but you don't really need to. As long as you can show the other one is the radical 20, you're good.
Okay.
All right.
So then let's move on to last side, which is BC.
And that is the square root of, let's see, BC. So let's do 3 minus 1, quantity squared, plus 2 minus a negative 2, so 2 plus 2, quantity squared.
Okay, so 3 minus 1 is going to give us a?
2 squared, which is 4.
Right, and?
4 squared, which is 16, which is radical
Still
20
radical
again.
20. So now we've shown that the opposite sides are what?
Congruent. So that would be AB is congruent to DC, and AD is congruent to BC. And if you had to explain it, you would basically say, okay, I used the distance formula to find the lengths of the opposite sides and found that they were congruent.
Perfect.
Just kind of explaining. Now, the last method is basically using that theorem that we kind of used in that last 2-column proof.
Okay.
Notice it says one pair of opposite sides are congruent and parallel. So really, this is a method where it's a combination, right?
Right.
So if we're proving congruent, we're going to use the distance formula. And if we're proving parallel, we're going to use the slope formula.
So here, but I'm only doing it for one set of opposite sides. So I would pick one set of opposite sides. So I'm doing 2 slopes and 2 distances.
Yeah.
Okay.
So we're still doing how many different things?
I'm still doing 4 things.
So this is 2 distances and 2 slopes. But here's the deal. The last 2 methods we did, we've already done the distances for all 4, the slopes of all 4. So we're not going to redo all of that work. This is more just talking about it. So if you wanted to use this particular method, you could prove, let's say, AD is congruent to BC and AD is parallel to BC, which would prove it's a parallelogram.
Right.
It just depends. You know, I have students that will use only method 1 or method 2 because they're only comfortable with one formula. You will have to know both formulas.
Yes. Okay.
So you want to make sure you're good with that. So if you were using this, if you go back real quick to this work, so let's say I was using AD and BC. We found AD was radical 20 and BC was radical 20. And then the slopes of those, if I go back, AD and BC were both 2. So the slopes of those, if I can go back here, the slope of AD was 2 and the slope of BC was also 2. You'd have to show this, but we've already done it. And then this would be able to justify basically that you have one pair of opposite sides parallel and congruent. Okay.